Okay, in section 3.2, in this section of the homework, we're going to do number 35 for an example. We have to find the domain, the range, the intervals where it's increasing, decreasing, or constant, and then evaluate it at f of 0, f of -2, and f of 2. So, starting with part A, finding the domain of this function. So our domain is all the possible x values. So going from left to right, always left to right. As far left, I can see an arrow here. That means it starts at -infinity because it goes all the way left and beyond. So there's no number too small that I won't find on this graph. And then I have x values all the way up until this x equals 0 line. If I say x equals 0, I can see it's not defined anywhere because I have an open circle here and an open circle here. So it's not actually defined there. It's defined up until 0. So it can get very, 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 very small. A negative 0.00001. But as soon as I hit 0, there's that open circle. So 0 is not included. And it's not included over here either. So it's not included on either graph. It's not included anywhere on this graph. So I have to exclude it from the domain, which I do that by writing 0 and then an open parenthesis to exclude it and a union. And I can see that the domain is going to pick up again right after 0 on this line right here. So I'll do another open parenthesis. So I exclude the 0, but say right after 0, the domain's defined again. And it's defined all the way up to 5 and including 5 because this time my circle is closed. So that includes the 5. And right after 5, x picks up right here. So x is defined everywhere except 0. So it's going to go over to infinity. So it goes from -infinity to infinity, except the only place it's not x is not defined is right here because it's two open circles and there's nothing closed. So there's no x equals 0 value. All right, moving on to the range. The range is all the possible y values. So I start as low on the bottom of the graph and going up. So again, these arrows are pointing down. So y can get as small as I need it to get. So I start at -infinity and then going up, 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 up. And I can see y is defined all the way up until I get to right here. Even though there's an open circle over here, it's okay because that y is still defined right here on this side of the graph. So there's still y equals 0 on the left side. So it stops right here, right? It's not defined anywhere at this y equals 5 line. So it's not defined at y equals 5. So I exclude the 5 by writing a 5 and then an open parenthesis. And I see it doesn't get defined again until I get up to this line. And that's when y equals 7. And that's a constant. So I'm going to union, but I don't have an interval now. I just have that one constant of y equals 7. So I'll use a set notation to say I want that this bottom interval plus the 7. So there's my range. Okay, and I'm going to erase all this and do my x intervals of increasing, decreasing, and constant. So where is this increasing? I'm going to use green for increasing. Okay, so when I do increasing, I think about my little guy walking along the line. He always walks from left to right. And when he's walking uphill, his height, his elevation is increasing. So, I'm sorry, my tablet is being mean. Not letting me draw a little guy. There we go. Still pretty bad, huh? All right, there's a reason I'm a math teacher, not an art teacher. There's my little guy. Okay, so he's walking uphill from -infinity. And he's walking uphill until he reaches this spot right here. These three things, the increasing, decreasing, and constant, they have three things that happen every time. And that is, one, they are always x intervals. So always look at those x values to define those intervals. 2, I always look left to right. That's actually true for the whole graph for all these. Actually, no, not for the range. Range is bottom to top. Okay, and then, but the increase and decreasing constant are always left to right, always the x intervals, and always open parentheses instead of closed brackets. All right, I always forget that E on parentheses. All right, there we go. So it's increasing until that guy gets to right here, and then that stops at x equals 0. And I'm looking at the rest of the graph. Over here, he's walking on a flat sidewalk. There's no increasing. And over here, he's walking downhill. So that's my only increasing interval. Now decreasing, let's do that one in orange. So decreasing is down here. So he's walking from left to right and he's going downhill. So that would be starting at x equals 5 and he walks forever. And it's constant. I don't know what color to use. On this line over here. All right, he's walking on a sidewalk. He's not going up or down. He's just a constant, and it's a constant value at an elevation of 7. So he is constant on that x interval. The x interval is 0 to 1, 2, 3, 4, 5. So from 0 to 5. The constant is 7, but the x interval is from 0 to 5. From x equals 0 to x equals 5, y always equals 7. All right, now the funnest part, I think. I'm running out of colors here, so let's do that. Okay, so I'm going to erase my markings on this graph so I can look at my next section here. Evaluating at f equals 0. That means my input is 0. What is my output? So that means there's some ordered pair that looks like 0, what? So I look on that graph and I say when x equals 0, I'm plugging in x for 0. That's right on this line. That's the x equals 0 line. What is y? And I look at the function and I see, oh, well, it's actually not defined. So I have to write undefined here because there's open circles. If one of those circles was closed, I'm going to give an example. Let's say this one was a closed circle, then I could say y equals 7. Whereas if this one was a closed circle, then I would say y equals 5. But since both of them are open, y is not defined when x equals 0. So x is not, 0 is not in the domain. Remember how we left it out over here in the blue one. Okay, now let's do f of negative 2. So now I go to x. When does x equal negative 2? So I'm looking for that ordered pair that has a negative 2 in the x spot, and I have to answer the question, what's in the y spot? So I go to x equals negative 2, so that's 1, 2. So that's right about this line, and I think, okay, well, what is y on this line? There's my y value right there. There's that point that says when x is negative 2, y is 3. So f of negative 2 equals 3. And my last one, when I plug in x equals 2, so I'm looking for that ordered pair, 2 what? And I have to fill in the what. So actually another way to think about that is 2 f of 2. The f of 2 is the y value. Okay, so I go to my graph and I say, okay, well when x is 2, that's this line right here. And that intersects right here, so y is 7 on that line. So there's my f of 2 equals 7.